Mr. Simpson here with the video for Chapter 2, Section 3, Atomic Structure and Symbolism. You see the learning objectives are listed here. Take a second and jot those in your notebooks. I've split the videos into two parts here for Section 3. This first video will deal with atomic structure, while the second video will focus entirely on average atomic mass. So we know the atom consists of two regions: the nucleus, the dense central core of the atom that contains the neutrons and the protons, and the area around the nucleus where the electrons are located. Nucleus contains the majority of the atom's mass, and you can see the masses of your protons and neutrons are listed here. Initially listed in the units AMU, atomic mass unit. This is a unit that we use because these values are so small in some more typical mass units like grams. You can see the conversion factor there between AMU and grams. Additionally, I've listed here the charge of the protons and neutrons. So as we know, the proton is positively charged and the neutron is neutral. So therefore, the charge in the nucleus is positive. Now, the majority of an atom's volume is occupied in that space around the nucleus, the electron cloud, where the electrons are located. You can see that we don't often talk about an electron's effect on the mass of an atom because this value is so small. But we do know that an electron is the negatively charged particle. This table gives you a little information here, summing up some of the things listed above for electrons, protons, and neutrons. Now, you may remember that the number of protons in an atom is represented by the atomic number. And you may also recall that that is the defining trait of an element. If I change the number of protons in the nucleus of an atom, I am changing the element. It is a different element at that point. Atoms are neutral. They're neutral because the number of protons equals the number of electrons. So my positively charged protons and my negatively charged electrons are equal in number. So the atomic number also represents the number of electrons in a neutral atom. The value here is the mass number. This is the total number of protons and neutrons in the nucleus of an atom. So you can see here, if we take the difference between the mass number and the atomic number, we'll end up with the number of neutrons in the nucleus. Here's how we would write the symbol of an element. We would represent the element with its symbol from the periodic table. Symbols are either one letter or two letters, with only one of those letters capitalized. So if it's a single letter, that letter would be capitalized. If it was a two-letter symbol, only the first letter would be capitalized. The mass number is represented in the upper left-hand corner, and the atomic number is represented in the lower left-hand corner. Now, here's an example of what it may look like if I were to look on a periodic table. Now, I am not given the mass number on the periodic table. I'm given the atomic mass, or as we'll see in our second video from this section, the average atomic mass. In this case, if I take my atomic mass and round it to a whole number, in this case it would be 11, then that's the value I'll use for the mass number. So in this case, for boron, I would have 5 protons, 5 electrons, and 11 minus 5, or 6 neutrons. If I were to look at fluorine here, I would have a mass number based on that atomic mass of 19, which would give me 9 protons, 9 electrons, and 10 neutrons. So you can see here that the number of protons and electrons are equal because I'm talking about neutral atoms. So what happens if my atom gains a charge? Well, at that point, it's called an ion. If the number of protons and electrons are not equal, the atom is electrically charged, and it's now referred to as an ion. They become electrically charged by gaining or losing electrons. So once again, the number of protons are locked away in the nucleus of the atom. That never changes. If that value changes, then I'm talking about a different atom. But electrons come and go, and so an atom can lose electrons or gain electrons. Now, one thing I want to emphasize here is in a neutral atom, my number of positive particles, protons, and my number of negative particles, electrons, are equal, and my atom is neutral. Now, these protons are locked away, so the number of protons in a particular atom is never going to change. But my electrons in that space around the nucleus are the object that is going to change here. Now, up to this point, you associate gaining something or the addition of something as being positive. But here we are gaining or adding negatively charged particles. So when I add an electron, the charge becomes negative. You'll see a case where I'll add 1, 2, or even 3 electrons, having a -1, a -2, or a -3 charge. So again, when you add electrons, the overall charge becomes negative. So you have to change your thinking on that a little bit. Addition in this case results in a negatively charged ion. Same thing if I remove electrons. So an atom can also become an ion when it loses electrons. We often associate losing something or subtraction with negative, but we are losing negatively charged particles. So when I lose an electron, my ion becomes positively charged. Again, I can most commonly lose 1, 2, or 3 electrons. So let's take a look at a quick example here. One thing, whether you're gaining or losing electrons, you get a separate name here. So an atom that gains 1 or more electrons and becomes negatively charged is an anion. And if you lose electrons and become positively charged, it's a cation. So now as I look at my atomic symbol here, you can see I still have the mass number in the upper left-hand corner. I still have the atomic number in the lower left-hand corner. But now I've added a charge here in the upper right-hand corner. So this is no longer the neutral atom, oxygen 16. This is now the ion, oxygen 16. So I have 8 protons because of the atomic number. I have 8 neutrons because mass number of 16 minus atomic number of 8 gives me 8 neutrons. And now I have to determine the number of electrons. So since I have a -2 charge, that means I've gained electrons. So I would have 10 electrons. Let's look at the symbol of a couple additional ions. Again, just to illustrate or highlight the point here of what these numbers around the symbol of the element are telling me. The 4 in the upper left-hand corner is the mass number. The 2 in the lower left-hand corner is the atomic number. Now, you can see here often emitted. So we want to get in the habit of always naming our elements or atoms or ions using a mass number, because you'll see in a second I could have different isotopes. But this listing the atomic number in the symbol is actually redundant and unnecessary, because once I put the symbol helium, that atomic number is not going to change. I can look it up in the periodic table, and that's what it's always going to be, 2. So you'll often see symbols where that atomic number is omitted from the symbol. So don't let that throw you off. As long as they give me the element symbol, I can always find that atomic number. So in this first example, the helium-4 ion with a 2+ charge, I have 2 protons, 4 minus 2 or 2 neutrons. And since I have a charge of plus 2, that means I've lost 2 electrons. So I would have 0 electrons in this example. Over here now I have 12 protons. 24 minus 12 is 12 neutrons. And again, I have a 2 plus charge. So instead of 12 electrons like I would have in the neutral atom, I'm going to have 10 electrons. Okay, we're going to get plenty of practice on this over the next couple days. So this is just an introduction, but hopefully you can see how these values all come together. Finally, I want to take a minute and talk about isotopes. These are atoms of the same element with a different number of protons. For example, here I've given you 3 isotopes of magnesium: magnesium 24, magnesium 25, and magnesium 26. So we just did an example with magnesium, so you can see here that we know magnesium has an atomic number of 12. Again, we could look that up on the periodic table had we not just used it. So for the magnesium 24 isotope, I would have 12 protons and 12 neutrons. For the magnesium 25 isotope, still have those 12 protons, but now I'm going to have 13 neutrons. And finally, for the magnesium 26 isotope, 12 protons and 14 neutrons. So as I said a moment ago, we want to get in the habit, if at all possible, referring to our atoms or ions with a mass number, identifying a specific isotope. If we don't have that, we can always refer to the atomic mass on the periodic table, but we want to start getting in the habit of referring to magnesium 24 or magnesium 25, a mass number, or if I was writing the name of it, referring to it as magnesium 24 in that nature. Okay, that's the first video on Chapter 2, Section 3. I wanted to split it up so it didn't get too long. So the next video for Section 3 focuses specifically on average atomic mass, that value we see on the periodic table and how it's calculated.